Hello and welcome. This is a Edexcel C3 June 2015 paper. Now, I would say I'm more than willing to take this video off YouTube if it eventually does upload before they upload the paper. But I think it's quite a hard paper, so willing to take the risk. Anyway. The first question is particularly difficult. As I wrote on the board there, we're told tan theta equals p. And we're asked, the whole question is based on converting these identities in terms of p. By subbing in, obviously, where you see tan theta to be p. The first one we're asked to do is quite a nice one, actually. It's tan 2 theta. Now, you either spot this or you don't. Personally, when I was doing the paper, I didn't spot it straight away. I just saw this and thought, oh my god, where am I going to go from this? And just went through the rest of the paper and then came back to it in the last 5 minutes and thought, oh wait, it's dead obvious. Well, the only thing we know tan theta 2 theta to be part of is an identity, so it's no harm in seeing where this identity can take us. So essentially what it's saying is tan theta plus theta is tan 2 theta, so we use tan A times tan B. Tan A plus tan B over 1 take tan A tan B. So essentially what this is saying is 2 tan theta over 1 take tan squared theta. Okay, sub in where we see tan theta be p, well obviously it's 2 times p, so 2p on the top. Take 1 take p times p, which is 1 take p squared obviously. So that is a simple one to do. This next one's a little bit more complicated. So 1b cos theta. These are all worth 2 marks, by the way. Now, the only thing that some of you may think, okay, well, the only thing that I know that links cos theta and tan theta together is sin theta and so we did sin theta over cos theta is tan theta, and we know that equals tan theta. We know tan theta equals p, and we want it in terms of p, and we want cos theta to be the subject, so surely what we should do is times both sides by cos theta and then divide both sides by p, so therefore we get cos theta as being sine over p, sine theta over p, but we want it all in terms of p, and the more people that are aware amongst you will realise we've got a sine theta in there. So you should know, obviously we can't do it that way, so there must be some other way. Bear in mind, we're only in C3, so there's no extreme identities that we'll have come across. So, the only other identity that we really, so you've got to think of it. So, obviously we've got to use tan theta somewhere. So, what other identity links tan theta and cos theta together? Maybe not specifically like quite as clear as that one we just tried there, but it's one that we build from really in C2. We introduce it as the sin theta squared plus cos theta squared equals 1. So we've got to rearrange this to get one of our new identities that links tan theta and cos theta together. Okay. Well, as we know, sin theta over cos theta is tan theta, so we've got to divide it all by cos squared theta. So the first one obviously is tan squared theta plus 1 equals sec squared theta, because we've divided it all by cos squared theta. Okay, so what does this sec squared theta actually mean? Well, we know it is equal to 1 over cos squared theta, so if we write that in, let's see where that takes us. Plus 1 equals 1 over cos squared theta. Now we want cos squared theta to be the subject, so we've got to do something to this equation to make cos squared theta the subject. Now, the way I'd like to think of rearranging this is when you're doing a differential and you get dx dy instead of dy dx, you do 1 over that to flip the fraction or do the reciprocal. We're going to do the same thing here, except we're not differentiating, we're just going to flip both sides. So this becomes 1 over tan squared theta plus 1. Now I'm not changing anything yet because I just want cos squared theta to be the subject. Okay? So what we're going to do is do 1 over both sides. So this is 1 over tan squared theta. It's the same equation because essentially that's over 1 anyway. So we're just flipping the fraction. So tan squared theta plus 1 is equal to cos squared theta. Now, we don't want cos squared theta to be the subject. We want just cos theta. So we can simply square root both sides. So therefore we've got cos theta is equal to the square root of 1 over tan squared theta plus 1. Okay? Right, well, let's simplify this. Obviously, square root of 1 is just 1. So we could rewrite this simply, if we wanted to neaten it down a bit, as cos theta is equal to 1 over tan squared, the square root of tan squared theta plus 1. Now, we can't just write cos theta equals square root of tan squared theta plus the square root of what? Tan theta plus the square root of 1, because it doesn't work like that. Right, so now we can sub in what we know. Now we know tan theta is equal to p. So therefore tan squared theta is going to be p squared, as we did over here somewhere. So therefore cos theta is equal to 1 over p, the square root of p squared plus 1. And that is your answer. Okay, so a little bit of thinking there, that is quite a nasty one. Really, I should think that's be worth at least 3 or 4, and that maybe 1 or 2. I mean, that is worth 2, but, you know. Okay, so hopefully you've got that. It's quite a nice one, actually. When you see, hopefully you can see where we've come from. Really, even if you didn't go to this identity straight away, you could have just built it up from the C2 identity like I did there, because I think going straight into that is a little bit, I mean, it only takes a second or 2, and you're less likely to make a mistake anyway. I mean, you might be a little bit more intelligent than I am and not have to do that, but, you know, up to you, whatever. So, okay, hopefully you've got that. Right. Okay, so the next one says cot theta take 45 degrees. So, okay, cot theta take 45 degrees. Okay, and we want that in terms of p. Well, the first thing I would do, because what we know is cot theta is 1 over tan theta. So what this is essentially saying is equal to 1 over tan theta take 45 degrees. Now, the thing with this is, don't be put off just because, I mean, you know 1 over cot theta is 1 over tan theta, but don't be put off because this is now in some kind of addition formula. Really, what we've already done the addition formula for tan theta. So we're just going to work out as though this simply said tan theta take 45 degrees, and work that one out and then flip it upside down. Okay, so if they break up in stages really. So tan theta take 45 degrees. Now what I do is write what A and B are. It's essentially because this is A plus minus B. So therefore A is equal to theta and B is equal to 45 degrees. Never mind the minus, it's not minus 45. That's just saying what to do in the addition formula. So the first one, you follow it on top. So the sign stays the same on top. Whereas if this was a plus, it'd be plus on top. So it's tan theta take tan of 45 degrees. Now, I'm not going to do it straight away, but in a minute we will put what tan 45 degrees into our calculator. We should get a nice number. 1 take tan theta times the tan of 45 degrees. Okay, so if you substitute that in your calculator, I can quickly down and get one. You should get quite a nice number actually. So tan 45 degrees is 1. So what we're going to do is write this as, so I'm really breaking it down. So tan theta take 1 over 1 take tan theta, because tan 45 is 1, so we can sort of ignore it. Now, we know tan theta is equal to p from our original, what we were told at the beginning of the question, so it's p take 1 over 1 take p. However, Oh wait, sorry. This is not 1 take p, this is 1 plus p, because the sign changes on the bottom. So it's p take 1 over 1 plus p. Sorry about that. Now, this is very good. This is in this form, but this is only up there. We still need to do the reciprocal of this, so we just flip it upside down. So it becomes 1 plus p over p take 1, and that is equal to what we're originally trying to find, cot p to take 45 degrees. So really all we did there is we just did tan d to take 45 degrees and did 1 over that. The key bit is realising, not getting worked up by this weird looking formula, because it's not only an addition formula, but it's an addition formula of a new identity we've learned. But you have to realise, well, what is this new identity actually come from? Well, it's just 1 over tan theta, so you just do what tan theta is and do 1 over that. Okay, hopefully that's understandable, and that's the end of question 1. So that's 6 marks for the exam. As I said, you either get that question or you didn't. As I said, part B, I could, if you were struggling a little bit on that question, part B is probably the bit where you fell down. But the other 2 parts of the question should have been absolutely fine. Maybe the last part would have been a bit tricky. So really, I would have rated it on just giving you an idea of how well you did on that question. So I hope most of you would have got part A. Pretty much all of you would have got part A. Some of you would have got part C, and a few people would have got B. I mean, that's just going off how my class did. So, as I said, I'm sort of representative of the whole country, but hopefully you get an idea for that. Now, if you want the whole questions, I'm more than happy to definitely not give you them over an email. But as I said, in case this video gets taken off, whatever. So anyway, thanks for watching, and we'll see you in the next question.